In December 1840, James Prescott Joule first suggested that heat could be generated using electric current. He immersed a fixed length of current carrying wire in a fixed amount of water and observed the temperature of the water rise. With this experiment, he was able to find the relationship between heat, current, and the resistance of the wire, which came to be known as Joule's law of heating. Let's find out what it is. A battery having a terminal voltage of V volt is connected to a resistor of resistance R in the circuit. That is, at point A, the energy of a unit positive charge is V joule. This energy is the electrical potential or the electrical energy per unit positive charge. In reality, the electric current in solids is due to the motion of electrons. So, one can say that a unit negative charge has an electrical energy of V joule at the negative terminal. When the electrons drift, they experience collisions with the positive ions oscillating about their mean positions. And the energy acquired by electrons is partly handed over to the ions, making their oscillations more energetic. This increase in the energy of oscillations of ions is manifested as heat, causing an increase in the temperature of the conductor. The heat energy released in a conductor on the passage of an electric current is called the Joule heat, and the effect is called the Joule effect. If the potential difference applied across the two ends of a conductor is V, it means that when a unit charge passes through the conductor, V joule electrical energy is utilized. If Q coulomb of the charge passes through the conductor in T seconds, then the electrical energy utilized in T seconds is equal to the heat energy produced during this time. W is equal to VQ. The corresponding current is I is equal to Q over T. Using the value of Q from the equation, Q is equal to IT, in the equation W is equal to VQ, we get W is equal to VIT. Now, according to Ohm's law, V is equal to IR. Therefore, W is equal to I square RT. Therefore, the electrical energy converted to heat energy per unit time is given by P is equal to I square R. Here, R is the ohmic resistance of the conductor, and its value does not depend upon V or I. Consider R as a constant. The heat energy produced per second is P is proportional to I square. The heat produced per unit time when passing an electric current through a conductor at a given temperature is directly proportional to the square of the current. The law is named after the scientist Joule, who also gave the conversion from joule to calorie, which is a more common unit for heat. According to that, 1 calorie is equal to 4.2 joules. Summarizing everything, we can say that the heat energy released in a conductor on passage of electric current is called Joule heat, and the effect is called the Joule effect. The heat energy released per unit time is expressed as the product of the square of electric current and the magnitude of the resistance of the circuit. Since the resistance of a circuit is constant, provided the temperature is constant, the heat energy per unit time is directly proportional to the square of the electric current. The more common unit of heat is the calorie. and 1 calorie is equivalent to 4.2 Joule. So, according to Joule's law of heating, if a current passes through a resistance, it will definitely produce heat. This means that every electrical device will produce heat. Can this heating effect be put to use? Stay tuned.
Keep imbibing. We believe in you.